The second question of the exercise asks to say whether these statements are true or false. So we are going to solve them and see if they are stating true or false. So let's just take a start. The very first one, it says that 0.599 is greater than 6.0. So this is false. Why? Because 0.599 is less than 6. If we take a number line and in here this is 0, so to this side we are having negative number, to this we are having the positive number. So 0.5, it is somewhere in here, and 6 would be, as we move, this line goes towards the positive infinity. So let's say if 0.5 is somewhere here and 6 would be somewhere here. So 0.599 is less than even 1. Therefore, this is false. It is not greater than 6, it is less than 6. Next, we are having 5 multiplied by 1999 is approximately equal to 10,000. If we multiply 5 by 1999, we get the result to be equal to 9,995, which is, and this value is close to 10,000. Therefore, in here the sign is approximately, therefore this statement is true. The third one states that 8.1 is equal to 1/10. So this in here is, we call it a mixed number, which is equal to a whole number plus proper fraction. So 8 is a whole number and 1/10 is a fraction. So how do we know if this is equal? 8.1, we know the value. In here, what is this equal to? So 8 and 10 in here. 8 is, we are having 1/10. So in here it is being multiplied and then added to the numerator. So 8 into 10 is equal to 80. 80 plus 1 is equal to 81. Now 81 divided by 10 is equal to 8.1. Therefore 8.1 is equal to 8.1. This is true. The next one, the D part, it is 6.2 plus 4.3 is equal to 4.3 plus 6.2. As you can see, in both sides of the equalities, the values are the same, only the order has been changed. So this is a true statement, because according to the cumulative property of addition, as long as the values are the same, if the order is changed, it doesn't matter. So 6.2 plus 4.3, whatever would be the value, it would be equal to 4.3 plus 6.2. Since in the addition property of commutative, order doesn't matter, therefore both the sides are equal. In the E part, 20 multiplied by 9 is greater than 21 multiplied by 8. So 20 multiplied by 9 is equal to 180, and 21 multiplied by 8 is equal to 168. So sorry, in here it is 180. So 180 is greater than or equal to 168. Therefore this is also a true statement. Next part, 6.0 is equal to 6. Both represent the same number, therefore this is a true statement as well. Next part is minus 12 is greater than minus 4. So in here again we will take a number line. This is moving towards the positive infinity, this is towards the negative infinity, and in here this is, let's say, 0. So in here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say this line is extended to somewhere in here. So if here it is minus 12 and in here minus 4, as we go down the numbers decrease. So the minus 12 is less than minus 4, because as we go towards the positive side the numbers increase. So this is a false statement. Minus 12 is not greater than minus 4, but it is less than minus 4. The next part is that 19.9 is less than or equal to 20. That is completely true. It is approximately equal to 20, and it is 19.9 is less than. So therefore this is a true statement. The next part is 1000 is greater than 9 multiplied by 5. 19 multiplied by, sorry, it is 19 multiplied by 5. So in here what do we do is that 19 multiplied by 5 is equal to 995, and 995 is less than 1000. Therefore if we say that 1000 is greater than 19 multiplied by 5, then that is true. And in here this is 19, not 199. So next part is square root of 16 is equal to 4. This is also true, because how can we prove that? If we take the square root of under root of 16, so it would be taking the square of 4, this gets cancelled and we get 4. So the square root of 16 is equal to 4, therefore this is a true statement. Or we can say under root 16 is equal to square of 4 under the root. These two get cancelled and we get 4, so this is also true. Next we are having 35 multiplied by 5 multiplied by 2 is not equal to 350. So this is we have to check it. If 35 multiplied by 5, so 5 into 5 is equal to 25, to carry 5 into 3 is equal to 15, 16, 17. So then we multiply it by 2. 2 into 5 is equal to 10, 1 carry, 2 7s are 14, 1 15, 1 carry, 2 into 1 is equal to 2, and 1 350. So the statement that says it is not equal to 350, it is false. The next part, 20 divided by 4 is equal to 5 divided by 20. This is not correct, because let's say we are having 4 and in here we are having, so 4 into 5 is equal to 20, and 5, sorry, if we are having in here 20 and in here 5, so it would be 0.25. Therefore this is not equal to, therefore we would say this is also a false statement. M part mentions 20 minus 4 is not equal to 4 minus 20. This is correct, because 20 minus 4 is equal to 16, and 4 minus 20 is equal to minus 16. 16 and minus 16 are not equal. Therefore this statement that says that 20 minus 4 is not equal to 4 minus 20, this is true. The last part mentions that 20 multiplied by 4 is not equal to 4 multiplied by 20. In here the cumulative property of addition and multiplication. In both of them, for addition and multiplication, the order does not matter, but for subtraction the order does matter. Therefore 20 multiplied by 4 is not equal to 4 multiplied by 20. Sorry, 20 multiplied by 4 is equal to 4 multiplied by 20. In here this not equal sign is not correct, therefore this is a false statement. As I mentioned, in the cumulative property, addition and multiplication, the order of the values does not matter. So 20, 4 into 0 is equal to 0, 4 into 2 is equal to 8. And if we do it like this, so 0 into 4 is equal to 0 and 2 into 4 is equal to 8. So both of them, it's the same result, therefore mentioning the not equal to sign is not correct. That is all for now. I hope it has been clear. Happy learning.